Welcome, everybody. We're ready to begin. I hope you've got your question cards. We'll collect these during the presentation, and be sure and print, because if we can't read your question, we can't ask the question. My name is Maynard Moore. I've been a member of the WesleyNexus board for a couple decades, and we are pleased to be able to make this presentation. We've got a lot of people online, so we'll have a hard stop at 5:30 and be ready to break everything down. So let me call on Eleazar Valentin Castanone, District Superintendent of the Frederick District. When he finished his seminary at Drew, he started his ministry in New York, but transferred into the Baltimore-Washington Conference when he finished work with the Board of Church and Society. So we're very glad to have his leadership on the board of WesleyNexus. And he will give us the invocation.
And just so that nobody gets confused, I'm the district superintendent for the Reservoir District. I know some of my pastors from the Frederick District will be happy to hear that I'm back in Frederick, but no. I'm in the Reservoir District, and it's again a blessing to be with all of you. So if you don't mind, would you please join me in prayer? Holy God, blessed God, we thank you for this opportunity, Lord, to be together. We thank you, Lord, for the opportunity to be together, Lord, to listen, Lord, to what we have been learning as human beings. We thank you, Lord, indeed, for the blessing of having Brother Francis Collins with us, Lord, for the blessing of having him here addressing us, Lord, and helping us, Lord, learn some of the things he has learned in his journey. We thank you, Lord, for all the people who have come to gather in this location, and for those who are online. We thank you, O Lord, indeed, for the blessing of being together in your presence, to learn together, to grow together, Lord, to learn from each other. We pray indeed, O God, that your Holy Spirit be upon us tonight, that we may be able to open our hearts, our minds, and our understanding to you, that we may learn, Lord, you are indeed teaching your children. We may indeed be able to teach this to our brothers and sisters in our communities and around the world. Be present with us tonight, Lord, for we pray all these things and give you thanks for all your blessings in the name of Jesus. Amen.
So I'm pleased to introduce now Dr. Wendy Figa. She's a doctor of veterinary medicine, having taken her degree at Ohio State University. She's a member of the Glenmar Church and Baltimore-Washington Conference. And serves as president of the WesleyNexus board.
Thank you, Maynard. I'm pleased to introduce our speaker for this evening is Dr. Francis Collins, and we are very fortunate to have him speak tonight. He did his doctorate at Yale University in physical chemistry, but while he was doing that, he became interested in the field of genetic science. So while he's finishing his doctorate in the physical chemistry, he decided to apply to medical school and go on to the University of North Carolina and explore genetic diseases such as cystic fibrosis, neurofibromatosis, and Huntington's disease. This research led him to become the director of NIH's Human Genome Project. And then he ended up as director of the entire NIH. He's the author of several fascinating books and also has received several prestigious awards. Dr. Collins.
Well, thank you for the kind introduction. It's an honor to be here for the Kent Weaver Lecture. Kent, I gather, is somebody that this organization very much prized, who served as treasurer and was a very dedicated part of the Wesley efforts. So honored to be asked to step into what has been an interesting series since 22. And I'm happy to look around the room and see people I recognize from some of my own interactions with the science and faith community and people from NIH. And I'm fortunate that Jennifer Wiseman decided to come back after being the person who spoke last night, and wonderfully so. I was watching remotely, and it's going to be a tough act to try to match the kind of awe that she created and the opportunity to really think deeply about God's creation. So I'll see what I can do. And I'm particularly happy that Bill Phillips, my friend, Nobel Prize winner from NIST, is here, and he's going to be the person who is the interrogator, the inquisitor during the Q&A. But I know he's counting on all of you to write things on those cards with really thoughtful questions, also legible questions, and then he can then be the person to put those forward, and I hope we'll have a good time with that part of the interaction. I think I'm going to speak maybe for about 45 minutes, and so hopefully that'll give us plenty of time for questions, although warning, sometimes I get carried away with a particular area and then it turns out a little longer than that, but I hope I won't make that mistake too badly. And, you know, there might be something in the way of a little surprise at the end. So yeah, here is what I'm going to try to put in front of you. I thought I would start out with my scientific journey and then talk about my journey of becoming a Christian at age 27, having been an atheist before that. And then coming to some of the more recent issues about science. You can't really do that without talking about COVID-19 because it's been such a tumultuous experience for our country and for the whole world. And unfortunately, it has, at a time where you might have hoped it would bring us together, it seems to, in many instances, have driven us apart. And I want to reflect about that and what it says about the nature of our society at the moment in terms of how we become so divided and so polarized. If there is some explanation of how that happened, particularly for people of faith, and then how might we try to turn that around individually to get back to a healthier kind of place. And then we will have the Q&A with Bill, and then yes, maybe a little surprise at the end. Before I get straight into that, I just want to pause for a moment because it's just been 10 days since we lost somebody very important to our planet and to me personally, and that's Jane Goodall. Jane and I were really good friends for the last 10 or 15 years. Starting off not friends at all, where she was very critical of NIH and what we were doing in terms of research on chimpanzees. And ultimately, with the strength of her argument and a careful analysis of what the science really says, I came to the conclusion that invasive research on chimpanzees was no longer justified, and NIH made a decision to no longer support that. Had a wonderful occasion with Jane at our house, sort of going through how that all happened. It took about 3 or 4 years to get to that decision, and those are all people who played critical roles in how that turned out. And there's Jane with her favorite. In this case, she's holding her stuffed cow, and Her famous monkey, Mr. H, is being held by someone else in the back. And Jane was also somebody who loved fun. And so knowing that I was a motorcycle rider, she was determined she wanted to be part of that. Now I want to make it clear, we were not actually moving. I would never have allowed her, with that precious head of hers, to be uncovered by a helmet. But for a photo shoot, it was okay. And Jane also admitted that one of the things that gave her a little bit of comfort after a very long day, and especially if she'd had to speak to 1,000 people, was at the end of the evening to have a little whiskey. And so there you can see we're celebrating that particular attitude of hers, which I found also wonderful to be able to cheer. I really miss Jane. She worked a full day on a Tuesday. She was supposed to meet with 1,000 students on a Wednesday. And that Wednesday morning, they went to wake her up, and she was gone. Jane and I talked about end of life. She was 91. She knew this couldn't go on forever. She was not afraid of death. She was curious about it. It's going to be really interesting to see what that experience is on the other side. What she was afraid of was long downhill slide of health and capacities. I think God heard her and took her so quickly, which is hard on all the rest of us, but it was probably what she would have hoped for. And causes me again to go back and read. Jane has this book called Reason for Hope. We need hope right now, and that was very much the theme of everything she was doing in her last few years. And her favorite quote, when people said, how do you have the strength at 91 to keep doing this? Said, well, this is my grandmother's favorite verse from Deuteronomy. As thy days, so shall thy strength be, King James Version. So just take it a day at a time. God will give you enough strength to do what has to be done. So there's also a podcast that I did with Jane on the BioLogos podcast, and here's my first opportunity to advertise BioLogos. If you don't know that particular organization, that's a foundation that I started 15 or 16 years ago, which has become a major gathering place for people who want to talk about how science and Christian faith can actually be harmonious, be in a place to speak important things to each other. And there's a podcast run by Jim Stump that has really fascinating conversations along those lines, and one of them was Jane and me. If you want another insight to her, I think she told some stories in that podcast you won't find in other places. Have a look at that. Okay, so that was a little bit of an introduction with a moment to reflect on a very special person, but let me now move to the journey in science for my own story, because people are always a little curious about this, and I think it is a little unusual. That's me, about age 8 or 9 there, standing at the front gate of the farm in the Shenandoah Valley where I grew up, with our barn behind there. This was a fairly austere kind of setting. We did not have indoor plumbing. Growing up that way, you don't think much of it, but other people are horrified. And I didn't go to school till the 6th grade, not because my parents thought they wanted to teach me faith perspectives. They weren't interested in those at all. They just thought they were better teachers than what the county schools had to offer. And I think they were right. They had met in graduate school at Yale. They were both really thoughtful, deeply intellectual individuals. My dad was a college professor at that point. My mother was a playwright. So I learned to love the opportunity to discover new things from my mother. She was my main teacher. There were no lesson plans, as far as I can recall. It was, what's interesting today? Let's do that. And sometimes we would do just one thing for 2 or 3 days in a row because it was still interesting. And then you kind of hit an obstacle, like, okay, let's do something else. We were doing math, let's do history, or let's do literature, or let's do the study of words and where they come from. She loved that as a writer herself. And she, after we learned, we in this case is my brother who's 1.5 years older than me, but she was teaching us kind of the same things at the same time, which was probably hard on him having this little brother in his way. She would say, let's go to the Oxford Dictionary and let's look up a word, and you're going to tell me without looking, did it come from Latin? Did it come from Greek? Did it come from Old French? Did it come from some Anglo-Saxon roots? And after a while, I got pretty good at it. You can figure that out just by the way in which a word sounds and a little bit of knowledge of history. So yeah, I loved that experience. And then got to be 6th grade, we moved in town, my grandmother had a stroke and needed to have somebody in the house. And then I qualified to go to the city schools. And so my mother said, okay, it's time, I'm kind of done now. And off I went to a really wonderful public school experience in Stanton, Virginia. And there, in the 11th grade, I learned to love science for the first time because of a chemistry teacher who was very gifted in helping his students understand that science was really a detective story. That you get some clues, and then you have the chance to try to figure out what's going on there. And I decided that's really what I want to do. Along the way, I also figured I had to do something sociable, so I learned to play the guitar. I was 2 years younger than the rest of the kids in my class, which meant I was socially pretty far out there in the outcast zone. Maybe the music would help a little bit. I'm not sure how much it did, but it's been with me since, so it was a good motivation anyhow. So off I went from there to the University of Virginia, majored in chemistry because that was the science I had first encountered. So I figured this is my calling, and it was great fun. I was pretty narrow in my horizons though, and this is something I warned students today about. I ignored life science completely. It seemed very messy. It is messy, isn't it, Bill? It is, isn't it, Jennifer? You guys went into astrophysics and other kinds of physical sciences for a reason. Life was going to be much more difficult to sort out. So I went all the way through undergrad and halfway through a PhD in physical chemistry before I realized I probably ought to look around a little bit and see what else is happening in science. And then I encountered this molecule. That's a chemical. It's deoxyribonucleic acid, otherwise known as DNA. And I didn't really have much knowledge about that, which is sort of shocking to think that you could have gone that far in science and not really learned much about molecular biology. But some of it was sort of being invented then anyway. That was part of my excuse. I mean, the genetic code was just being figured out when I was a PhD student. And so here was this molecule that was so compelling, carrying information in its series of chemical bases that are abbreviated A, C, G, and T. But think of it as a language. It really is. And those 4 letters make up the language of life for every living organism, and they all use it in the same general way in terms of how that instruction book gets transcribed into RNA and then translated into protein to do amazing things. And that was so elegant, and I suddenly realized I was wrong. I thought biology was devoid of any interesting fundamental principles. No, it has the most interesting fundamental principles. It has an information molecule called DNA. And that comes about because of the way in which you inherit it from both parents. And it made sense to me all of a sudden that there's a mystery here that must somehow be approachable by science, which is you all started out, all of us did, at one cell with this instruction book. And nobody was quite clear at that point how many letters there were in that instruction book, a lot. And it seems to be enough to specify all of those developmental stages resulting in an incredibly complicated organism, each of us. That's amazing. How does that work? Talk about a challenge for information science. And we also know, and I was learning more about this, that misspellings in that instruction book can cause serious problems. Sickle cell disease, 1 letter out of the whole thing, that is a T that should have been an A, is sufficient in 2 copies to cause somebody to have a lifelong disorder associated with absolutely gruesome pain and a short lifespan. So I figured this is something I want to do more with. I wonder, do I, skip the plan I had about physical chemistry and go do a postdoctoral fellowship in a life science lab? That was one possibility. But I thought, if I'm going to make a change, if I'm going to do something really dramatically different, I want to keep all the windows open. I narrowed my horizons too soon. Now let's just bring it on. So I'll go to medical school. I can do anything with that. I still wonder how that admissions committee at the University of North Carolina, hearing that story, said, okay, sure, come on. And things are a lot more competitive these days. I don't think I would have made it through, but they did. And there I did find, yeah, this is really what I've been looking for. It is science, but it's very digital because of DNA. But it's about people. And I might actually have the chance to do something that'll help somebody someday. Even though this is 1973, most people are saying, this DNA stuff is fine, but it's going to be 100 years before it matters in clinical medicine. Well, turns out they were wrong. So I studied internal medicine. That's my specialty. I'm an internist. I did a residency. I was a chief resident. And then I did a fellowship. There's a lot of training here. And eventually, I got a real job at the University of Michigan as an assistant professor, teaching medical students, taking care of patients, and doing research. And the research I was most interested in was trying to find the cause of genetic diseases for which we had no answers. So I guess I got called a gene hunter there at U of M, and it was hard. In the first 2 or 3 years, I made almost no progress trying to find the cause of cystic fibrosis. And people kept saying, you got it yet? And I would say, no, it's really hard. And we'll say, well, how hard can it be? Okay, I finally decided I need a visual. So this is a hayloft somewhere outside of Ann Arbor. And I went there with a needle and sat in the haystack and held up the needle so that everybody would know how hard it really is to try to find these answers. And yes, that's a real chicken. But little by little, having brought into my lab a couple of really talented people, and then importantly, figuring out that this is such a hard problem in 1987 that maybe it would make sense for the groups that are working on it to kind of collaborate instead of competing with each other. And one of them, Lapchi Choi in Toronto, thought that was a great idea too. And so his lab and my lab basically merged. That wasn't done in those days. And decided we would work on this together. And our people all got to know each other. We had lab meetings in a kind of rundown Holiday Inn in London, Ontario, because it was halfway between Toronto and Ann Arbor. So we could all get there in a day and talk science and then go home again without having to pay any money for staying overnight. I'm not sure the Holiday Inn appreciated that, but it was okay. And it began to work. Lesson here, collaboration really does allow you to go faster, as long as you're not going to worry too much about who's going to get all the credit. And in 1989, we had it. The cause of cystic fibrosis emerging and described in these 3 papers in Science magazine. And what was it? Well, for most people with this disease, just 3 of those letters of the genome out of what we knew by then was about 3 billion. That's the size of the genome. 3 in this particularly vulnerable spot in a gene that had never been actually looked at or even known to be there before was the cause of this disease. I have to do a little leap forward here because it is so gratifying to be able to say this. Here we are in 2025. It is now the case that 90% of people with cystic fibrosis who have that particular 3-letter deletion have access to a drug which took all of 30 years to develop in a wonderful synthesis of efforts from academia, funded by NIH, philanthropy, the Cystic Fibrosis Foundation, and then ultimately industry, a drug called Trikafta, which makes it possible for people with cystic fibrosis to plan for retirement instead of planning for an early funeral. It's incredibly gratifying to see that, but also a really important reminder about how hard this is. Medical breakthroughs don't just fall from the trees. It takes that investment, a lot of going down blind alleys and then pulling yourself back and trying to come up with a better hypothesis. That's how it works. I'll come to it a bit. I'm concerned that maybe, for the most part, our country has lost that sense. And we're in a bit of trouble now in terms of whether that kind of breakthrough would happen in 2025 or whether there would be too many inhibitory influences to make that kind of progress. Yeah, I worked on other diseases back then. This is the disease, Huntington's disease. This is Nancy Wexler, who's in a family with Huntington's disease and yet was the major organizer of an amazing collaboration there that led to the discovery of that gene in '93. And then tragically, about 7 or 8 years ago, it became clear that Nancy herself is affected. I actually went to see her just 2 weeks ago in New York, where she has 24/7 care. She has pretty advanced Huntington's disease, although her mind is still very sharp. This is really hard for somebody who had done everything you could imagine to try to find the answers, and they didn't come quick enough for her. The very day I went to see her, there was an announcement by an Amsterdam company of a new gene therapy that for the first time shows benefit in Huntington's disease, which may be a little late for her to benefit from. And I worked on this disease, neurofibromatosis, which one of the more common genetic diseases that you probably haven't heard of. And more recently, I've been working on progeria, a condition which causes children to age at about 7 times the normal rate, even though they're otherwise developing as far as their capabilities and their intellectual capacity, just like a normal kid. In that picture, that's Sam, who at that point is 15 years old. Sam died 2 years later. Most kids with progeria before treatment will die at age 13, 14, or 15 of heart attacks or strokes. We are on the brink, potentially, of curing this disease, maybe even with a clinical trial within about a year that will actually go and fix the misspelling in this particular case, which is just 1 letter out of those 3 billion, for which we now have a gene editor that can be infused, directed by an appropriate virus that goes to the right places in the body, which is the heart and the aorta, and may very well stop the disease or even reverse it. We're going to find out. It works great in a mouse, but we've cured a lot of mice from a lot of things, so one has to be careful not to get too carried away with that. So that's what I did, and that's what I continue to do. My lab has been active ever since 1984, working on these problems, and that's been a very good way to stay anchored. But I got pulled into some other things that were much more demanding and for which I was very poorly prepared, namely running the largest big science effort in life science that had ever been mounted, the Human Genome Project, which got started in 1990, initially under the direction of none other than Jim Watson, as in Watson and Crick. And then after he got into a bit of a pickle with his boss by insulting her one too many times, he was gone, and I was asked to step in and serve in that role, which was not something I thought was a good fit for me, but how can you walk away from the opportunity to lead the effort to read out the entire DNA instruction book with a whole lot of other milestones along the way? I will tell you, it was a bit of a challenge then to convince the scientific community this is a good idea. A lot of them didn't think so. Ultimately, part of my job was to recruit some of the best and brightest to work on this project. And that was true out there in many academic institutions. It was also true at NIH itself. And I'm glad to see Ken and Aaron right here, who were part of this effort in the earlier days of the Genome Project, trying to make this happen, which meant you had to invent all kinds of technology that wasn't invented yet. And you had to figure out how to do this in a really big collaboration. Because ultimately, when this succeeded in 2003, it involved 2,500 scientists, 20 research institutions, 6 countries, took 13 years, and it was my job to be sort of the field general of all this and make sure it actually happened. And it did. And we got done actually 2 years ahead of schedule and $400 million under budget, which made the Congress very happy. And we gave all the data away. That's really important. There was also a commercial effort that was underway at the same time. They were going to have their part of it only available if you could pay. That didn't seem right to us. We're talking about our shared inheritance, our own instruction book. That ought to be available to anybody who's got a good idea about how to apply that for human benefit. And that's what we stuck with, and that's how it turned out. So I stuck around with the Genome Institute for another 4 or 5 years, working on projects to try to understand how to read this language, which was kind of all new. And then had another calling in 2009 from President Obama to serve as the director of the entire NIH, which is a pretty daunting thing to imagine, the largest supporter of biomedical research in the world. That meant I had to know stuff about neuroscience and immunology and really hard and complicated topics that I could not have said I was an expert in, but it was a great moment to remember my experience with my mother. Learning new things is really fun. Okay, here's your chance. You've got a vast number of opportunities. So yes, I got called to serve, and then, to my surprise, I got reappointed by President Trump in 2017, and then reappointed again by President Biden in 2021, and then ultimately stepped down in December of 21. That's 12 years, the longest anybody had ever served as NIH director, and certainly the only time anybody had ever been appointed by more than one president, and it was time for somebody else to step in. But while I was there, I got to do a lot of interesting things, because NIH is this big, complicated organization. Some of you know that because you worked there. There are 27 institutes and centers. The NIH director doesn't really control the budget for those institutes and centers. They get their dollars from the Congress. So your role is really to kind of have a bully pulpit and do some cajoling and some convening and say, you know, here's a project that we really ought to do, and none of you institutes are actually positioned to do it by yourself. So let's see if we could do it in a collaborative way. And my predecessor, Elias Zerhouni, made that easier by establishing something called the Common Fund, which is basically money that you should use for things kind of like your venture capital space that might not happen otherwise, but if they work, are going to be really important. So I had fun with that. I got a chance to start a whole new part of NIH called NCATS, the National Center for Advancing Translational Sciences, trying to deal with this issue about basic science getting stuck and not making its way to the clinic. That's what translation means in this particular context. With Obama, I got to start the Brain Initiative, which is now 10 years old, trying to figure out how all those 86 billion cells between your ears do what they do. And we're making pretty good progress on that. That's the most complicated structure in the known universe. I don't know, Jennifer, are galaxies more complicated than the brain? No. We can have a conversation about that.
I'd say the brain is more complicated.
Okay, she's acknowledging the brain is going to win the sweepstakes here. So we're going to take a while to get the answers to that, but we're beginning to, and it's beginning to shed some really important fundamental light on what happens when things don't go right in the brain, like schizophrenia, for instance, or Alzheimer's or Parkinson's or PTSD or autism. And then we started a project called All of Us. This is a particular dream of mine, to have a very large-scale cohort study, currently up to 880,000 Americans who are our partners in this. And they agree to make their medical records available. They provide a blood sample that results in a complete genome sequence. They answer all kinds of questionnaires about their health behaviors. They wear Fitbits. And that is all information, anonymized, that's access to researchers to try to figure out, okay, one size fits all probably isn't working so well for us in terms of prevention and treatment. Here we've got the chance to figure out individual differences and how they affect the outcome. This is now about 5 years along. It will get better and better over the coming years. And then things started to happen in some of those areas that I didn't know would happen in my lifetime. The advance of CRISPR, this amazing ability to be able to do kind of find and replace in the genome just like you would in your word processor, led to FDA approval of not one but 2 different protocols to cure sickle cell disease. Just an astounding thing to be able to say out loud. Still very complicated, very expensive, and we're working on ways to make it much more accessible and less toxic, but it is there. And then I'd also got the opportunity, which I hadn't planned on, to work in the White House for a year as the president's acting science advisor, which provided some other things that I'm excited about seeing go forward in terms of things that can help people avoid certain illnesses or to be treated more effectively if they fall sick. So that's kind of my scientific story, except for the last part, which is I continue to work at NIH as a person overseeing a research lab, working on diabetes and on this rare disease I mentioned earlier called progeria. And that was what I thought I would still be doing, but in late February, I was made to feel extremely unwelcome in that circumstance. And so I left NIH on March the 1st, and I'm currently unemployed. So that was the science part. How about the faith part? How did I come to be a Christian? I think I mentioned that I didn't grow up with any faith tradition. My parents were not dismissive or denigrating. They just didn't think it was worth spending time on or very interesting. So I adopted that same view. And little by little, as I got more interested in science, I became a bit materialistic about the only thing that's worth talking about is what you can measure. A lot of scientists do get into that same mindset. I saw them around me. I figured, okay, that works for me too. So I wasn't just doing science, I was doing scientism, sort of a philosophical mindset that denies the possibility of anything outside of what science can measure. And I was pretty comfortable with that. And I was not getting challenged much by the people around me as a graduate student in physical chemistry. And then I went to medical school, as I said. And then something started to bug me because I was finding myself at the bedside of patients who were suffering, wondering, what's that about? How would I handle that? Patients who were clearly approaching the end of their lives. And some of them are angry, and some of them are depressed, and some of them seem to be at peace. The ones who were at peace, strangely enough, weren't that way because they believed that our medical interventions were going to miraculously save them. They believed that Jesus was going to be the person they could lean on, and that gave them comfort when we weren't able to otherwise help them very much. And I thought, well, that's a pretty strong psychological crutch, I guess. Must be what it is. Until one afternoon, I had a patient I was assigned to, who was a grandmotherly character, reminded me of my own grandmother. She had terrible heart disease, and she was having multiple episodes almost every day of chest pain, for which we were not doing a very good job of giving her relief. And after one of those, I'm sitting at her bedside, and she shares her faith, as she often did. And as she's doing so, looks at me, said, "I've shared my faith with you, but you didn't say anything. What do you believe, doctor?" Just like that. Looking me straight in the eye. I realized I had no answer. Suddenly the ground felt very shaky under me. I think I probably said something like, "I really don't know." Saw her look of surprise, got out of the room as fast as I could. I think I just realized that's the most important question in my 25 years I've ever been asked. And I've spent zero time reflecting on what the answer might be. I know there are people who believe in God. I assume that's all just some childhood indoctrination. But some of them seem like pretty substantive people. Maybe I'd better explore this a bit so I can strengthen my atheism. That was my goal. I did a little bit of reading. I didn't find it particularly helpful, but I thought, I need to talk to somebody. So I knew there was a Methodist minister. Methodist, y'all, here we are at this particular gathering, who lived down the street and seemed like a nice guy, Sam McMillan. And so I decided I'm going to go talk to him. Hardly knew him. He hardly knew me, but he said, "Sure, come into my study." And I then proceeded to ask him a whole lot of blasphemous questions. And he proceeded to give gentle, thoughtful answers, basically saying, "I think you're on a journey and you're pretty early on it." And then he said, "You know, your journey seems a lot like one that other people have traveled. Maybe it would help you to hear what their reflections are. Here's a little book that you might want to read." And yes, it was Mere Christianity. What else? I took it down. I walked back half a block to my house. I sat down, I opened it up, and started reading that first chapter. Right and wrong as a clue to the meaning of the universe. Whoa, that's big stuff. I've never thought about anything quite like that. And 3 pages in, I realized I was in real trouble. That my arguments against God were those of a schoolboy. And this Oxford scholar somehow seemed to be inside my head half the time and was basically, little by little, making a case that atheism was the least rational of the choices and belief in God made an awful lot more sense. Well, that was a bit of a shock. And let me be clear, I did not become a Christian that afternoon. It took me 2 years to go through that journey, asking a lot of questions, being afraid of what it meant. But I began to realize that it wasn't just from arguments from C.S. Lewis that were bringing me in this direction of beginning to think that maybe there is a creator. There's information in nature that I had studied and hadn't paid attention to in exactly this way that were pointing in that same direction. What are those pointers? Well, the big one, there's something instead of nothing. Why should that be? Science cannot help you with that one. Another one is that the universe had a beginning, the Big Bang. We really don't know how to interpret what came before that. People are trying, but basically it seems as if there's got to be a first cause. What was the first cause for the universe? It can't be something that is itself bounded in time and space, or you've not solved the problem. So that quickly leads you to the idea the first cause has to be outside of nature. Supernatural is the meaning of that word. And also something outside of space and time. Wow, that sounds a lot like what people are talking about when they talk about the Creator God. And then my own study of physics and chemistry began to come back to me, and this is Wigner's phrase. Matter and energy follow these beautiful mathematical equations that I'd studied. My whole PhD was studying quantum mechanics. Why should Schrodinger's equation actually describe truth about what is around us in the universe? All described in second-order differential equations, which I absolutely loved. But why should that work? More simply, why should gravity, as a first approximation, be an inverse square law, and that describes the attraction of two bodies based on masses m1 and m2? You have to think about it. Why should electromagnetism follow the incredibly beautiful equations that describe it, the Maxwell equations? Why should that be? As a mathematician of sorts, because you kind of had to be one of those to be a physicist, I admired those equations. I thought they were not just nice, they're beautiful. Huh? It seems like maybe whatever got this universe going was a mathematical mind. And then there was one more, which was an even bigger kicker that I had never really heard about, which is this idea of fine-tuning. Come back to gravity. So what is that equation? It says the attraction is m1 times m2 divided by r squared times a constant, the gravitational constant. Well, you can't derive the value of the gravitational constant from theory, at least not yet, and most people don't think you ever will. It just is what it is. You measure it. But a few decades ago, people started playing around with the idea. Suppose it was a little different. How would our universe look? What would life be like? Well, guess what? There would be no life. That constant and 5 others are on this incredibly knife edge of improbability, where if you tinker with it just a tiny bit, making it a little bigger or a little smaller, you get nothing after the Big Bang except a lot of particles flying apart and maybe coming back together in a big crunch, if G is a little too big. And there's no interesting options there. It's not that you wouldn't get life like we know it. It wouldn't get any kind of complexity that could give rise to anything you would want to call life. So how is that? How could those constants have precisely the value they have to have for something interesting to occur? You're forced, I think, to 2 conclusions. One is the dials were set by that mathematician, who's also a really good physicist and also interested in complexity, called God. Or you have to say, and this is what the atheists will say, there are multiple other universes out there. They have different values of those constants. We're here, so we are the one that got lucky, otherwise we wouldn't be having the conversation. But which of those requires more faith? If you were a fan of Occam's razor, which is like you look at 2 options and you pick the one that is the most simple and straightforward, I think the God hypothesis kind of won for me compared to the alternative. But that got me to a God who's maybe a deist kind of a God. Einstein would have approved of this so far, I think. Stephen Hawking would have approved of this mostly so far, that there is an intelligence behind the universe. But does that God care about me? That's a much more difficult question to find these same scientific signals. But I ultimately realized there were signals there too. And one of them was in that first chapter of C.S. Lewis's Mere Christianity. Right and wrong as a clue to the meaning of the universe. Why is it that all human societies have always had this idea, and it's a really important one, that there is a thing called right and a thing called wrong? we differ based on culture in terms of what we put in the right column and what we put in the wrong column, but we don't disagree that there's something important there. And when we ourselves decide to do something in the wrong column, we make excuses about, well, it was because she said that to me first, or I was tired. So that almost proves that we believe that this applies to us. It's a moral law, a law that we regularly break, but it's there. So where does that come from? Now, the evolutionists will try to explain this by saying this is basically an influence on human behavior that has allowed us to flourish and survive and propagate and reproduce. And you can kind of see how that works for things like kin selection, where you're nice to your family because they share your DNA. Or even group selection, although there's some argument about that. But those evolutionary arguments require you to be hostile to outgroups. Otherwise, you would not really make the whole thing work for propagating your own DNA. And that's where I have trouble fitting this together. One of the things that we look at as the most dramatic examples of what it means to be human and the way we're called to do, it's usually some sort of dramatic form of altruism, maybe even radical altruism, maybe even self-sacrificial altruism. I mean, which of you, if you were walking down the road and saw a 5-year-old dash into traffic with oncoming cars, would not try to do something? Of course you would, even if it's somebody you never met before and it's somebody of a different group. You're called to do that. Or if you see somebody drowning in the middle of the river and you think you might be able to save them, are you just going to walk away? No, you're going to try to do something to help. At least you feel like you should. Now, maybe we don't always do this, but we feel like we should. And when somebody does, we go, yeah, that's what we're called to do. That's who we are. Where does that come from? Those radical altruistic responses are a scandal to evolutionary pressures. They don't make sense, and yet we believe in them. So if I was looking for a signpost in my own heart that God actually is sending me a message about his calling of what he wants me to be, and I find this moral law there, that got my attention. And it also says, doesn't it, that if it's God that is the source of this, then God is good and holy. And God wants me to follow that lead. Okay, that one got me. I'm now 1.5 years into my 2-year effort, and I'm having more and more trouble fighting off this sense that the hound of heaven is after me. And there was one more signal that also, I think it touched me even in earlier times, which is beauty. I don't think we should put short shrift to this part of the way in which we are called to recognize that we are more than just atoms and molecules. Why does beauty make such a difference? Why, when you see a particular beautiful sunset, or when you hear a piece of music that just lifts you completely out of yourself, why does that have such power? And why does that give you this sense of longing, which Lewis called joy? It's almost exquisite. It's almost painful. It's this sweet moment of longing, like, ah, oh, I think that's what I'm made for. And then it's gone after a bit. And it was both the most remarkable kind of longing, and yet you realize most of your time you're not there. What is that? That feels like a calling. And then I began to realize that beauty is not just about music and the sunset. It's also about science. Look at these images. So on the left is a beautiful stained glass window from York Minster. On the right, an unfamiliar view of DNA, where you're looking down the long axis instead of from the side, so that double helix is spiraling in front of you in a way you can't quite see. But isn't that exquisite? And anybody who does science can't help but be astounded sometimes by the beauty of what you're doing. When Jennifer talked to you last night about those astounding images from Hubble and from the James Webb, you couldn't help but be awed. You just can't possibly go through that without that sense. Now, maybe you don't tie that directly to a connection to God, but I increasingly felt it was. It's another, not a proof, but an evidence. So after 2 years of this struggle, fighting pretty hard all the way along, recognizing though that I was probably not going to be able to go back to being an atheist or even an agnostic because the case was too strong. And feeling this greater and greater urge to just give in and embrace the option. And along the way, learning about the person of Jesus. Jesus, who I thought was a myth until I really began to learn the real truth of his life, his death, and his resurrection. And suddenly all that made sense, because I got to tell you, I was recognizing that God was good and holy and recognizing that I was not, and that was a bad moment. Like just when I think there is a God who cares about me, I feel like the only appropriate response for God would be judgment. And then Jesus appears in a way that I've never understood before. And finally it made sense to me when people said to me when I was a kid, Jesus died for you. I thought, that makes no sense. Now it made perfect sense. So on a hike in the Cascade Mountains, on a beautiful day about this time of year, the beauty of the scenario, of the scenery just overwhelmed me. And I felt I can no longer stand still. I've got to take the leap. And it is a leap. You're never going to be in the place where you know for sure that you're leaping into something you can prove. But it was absolutely the thing I needed to do. And I knelt the next morning in the dewy grass, and I gave my life to Christ. I was 27. That was a while ago. And over those years, I'm happy to say, I've never encountered a circumstance where what I know as a scientist is in conflict with what I know as a serious Christian who believes that Scripture is God's Word. I think there are plenty of times where we perceive a conflict, oftentimes when there's a debate about how to interpret particular parts of the Scripture, but I haven't encountered a place where that could not be worked out. Maybe not in, okay, I see the perfect answer, but I see several possible answers. And I've come to love the idea that God, as Francis Bacon said, gave us two books. The book of God's words, the Bible, which I try to read every morning, and the book of God's works, which is nature. All those far-flung galaxies, all the way down to particles inside the atom, and you and me. And I wrote about this in this book called The Language of God. And to come back to the title that I gave for today's presentation, it is wonderful to be able to speak to you about this because the God of the Bible is the God of the genome. It can be worshipped in the cathedral or the laboratory. His creation is majestic, awesome, intricate, and beautiful. So I hope that very personal story has some resonance with you. Everybody in this room, everybody listening, has a different way in which they come to try to understand what is true and good and beautiful. My way, I've learned to find out, is pretty unusual. Not that many folks have traveled this particular path, but God calls us all in the way that God has in mind for us. And for me, it was a blessing to have traveled this path. I think it helps me as somebody talking to non-believing scientists to be able to say, this was not something I learned as a kid. I'm jealous of those who were, because I think their faith, your faith, many of you, has that long sweep of your whole life existence to build upon, and I didn't really get started until I was a quarter century alone. But maybe it's a little bit of an encouragement to skeptics to hear that it's possible to come to this on the basis of rational arguments as an adult. Well, okay, let me move on to talking about where we are in our country, and particularly what the story is about possible conflicts that we need to wrestle with. And I got to talk about COVID. So this brings us back to the first part of 2020. I think many of us have tried to suppress our memories of this because it was such a difficult time when the first indication of this outbreak occurred. And let's be clear, 2020 was an absolutely traumatizing year for everybody. I think most of us lost people to this illness. And many things happened in terms of society, closures of businesses and schools. disagreements about the right way to keep safe, an uncertainty about whether there was going to be a vaccine that would work or not. Let me just say, here are some settled science about the vaccines, because I think we ought to be sure we stick to the things that we know, and there's still a lot of confusion and, frankly, a fair amount of misinformation. It was a terrible pandemic. More than 1 million Americans died. Probably about 1.3 million is about the best bet we have. And of course, you can argue in some cases, well, was it COVID that was the cause of death, or were they actually dying from something else and COVID just jumped in at the last minute? The vaccines, which I had a huge role in as the NIH director, supported by Operation Warp Speed, which was the boldest program ever mounted to try to handle a circumstance like this, pulled together all of the experts in academia, in government, in industry, and that was a big part of my job, was managing those large, complicated collaborations, making sure that everybody who had a skill to offer was in, and they were. Let me tell you, it was incredibly impressive to see. People dropped everything, worked 100-hour weeks. I did, many other people did too. Didn't worry about who's going to get the credit. Operation Warp Speed provided the funds. We could take risks, like actually starting to manufacture a vaccine before you even know if it was going to work, just so you would have the doses in case it did start to work. And what happened? A rigorous, probably the most rigorous trial mounted for a new vaccine. 30,000 participants in the Moderna trial, 40,000 in the Pfizer trial. They didn't know if they were getting the real shot or a dummy shot. And the people administering it didn't either. It was all barcoded. And then you wait for about 4 months to see, did the vaccine actually protect people from getting sick? Because you're tracking everybody. And until you get to the point where there have been enough cases that you think you're going to have enough power to be able to get an answer, you don't know. You cannot unblind the data. That would be completely cheating the whole thing. So it's all done that way. And I prayed so hard that year that this would be a circumstance where this vaccine would work, recognizing that most of the time vaccines don't work, or they work only marginally. Even your flu shot, I got mine a week ago, maybe it'll be 50% protective, and we would have taken that if that's what we got. But instead, 92 to 95% effective in preventing serious disease, hospitalization, or death. Now that was at the point, this is November 2020, where there's basically just one virus, the original Wuhan virus. After that, other mutations happen, ultimately Omicron, which is almost like a different virus because it has so many different changes to it. So the vaccines are less effective against those further ones, which I think then added to people's being a little distrustful about whether they've been given the straight scoop. In fact, it's now happening and people are getting infected who are vaccinated, and we all know that has happened. But it's still the case today that if you're vaccinated and you get exposed and you get sick, your chances, well, first of all, your chance of getting sick is about 50% less, and your chances of actually ending up in the hospital are about 90% less. But you can still get some symptoms, and you can still need to isolate so you don't infect other people. And that, I think, that difference caused people to begin to doubt their confidence in what these vaccines could do. In terms of the safety issue, remember 30,000 people, we could look for any safety signal. There really wasn't anything of concern in that number. Now, once we got to 300 million Americans, it's clear there's a rare 1 in roughly 10,000 young men who get this myocarditis from the vaccine. By the way, COVID causes myocarditis more frequently than that, so comparing the two, you're still better off with the vaccine. But that was an alarming thing. I can tell you now, the good news is, every one of those, as far as I've been able to find out, is reversible. That does not leave a lasting effect. And no young men died of this effect, but it did sound alarming. Other side effects, sore arms, yep. But for the mRNA vaccines, they have a remarkably good track record as far as safety. And how many lives were saved? Well, Commonwealth Fund has done their analysis. Comes pretty close to most of the others. 3.1 million lives saved. Probably some of you could be one of those. I could be one of those. How do you figure out who got saved? But you can look to see what's the difference between those who got vaccinated and those who didn't, and you can do the calculation. And the saddest thing, more than 230,000 people who chose not to be vaccinated are now in graveyards. That's just between the summer of 21 and the spring of 22, which is when we had a lot of COVID around. That's Kaiser Family Foundation's data. And why did they decide not to? Good, honorable people. They had lots of information that made them uneasy about whether this is something to trust. And the social media was doing their job of adding to that uncertainty by lots of stories being spread around, many of which were not true. The public communication about COVID, and I'm part of that, was less than perfect. At times I wish we had said things differently than we did, and it began to be the case that people were not sure they could trust our voices either. And meanwhile, our country was getting more and more polarized. And politicians, I'm sorry to say, were making that worse. Our politicians are more polarized in the country. And even COVID, which never should have been in there. Medical research, public health, should never be a political issue, but it became that. And so we got in a culture war and it killed a lot of people. That shakes me up now to say that. And when I stepped down as NIH director in December of 21, I felt like, I gotta figure this out. I gotta understand what's going on. I got involved with a group called Braver Angels to try to meet with people who were so upset about the public health response and try to listen to them, and I learned a lot. And I learned that there were things that really didn't go the way they should have. And I also learned that a lot of the things that were happening were based upon inaccurate information, but we had not apparently been able to overcome that. So let me turn then to the current state of our nation and our world, because COVID was part of this, but it applies across many other areas as well. What's happened to us and what do we need to do about it? I think, first of all, we're divided. We're very seriously divided. There's a group called More in Common, which aims to try to look at societies and figure out, are there certain categories of people who fit in a particular space? In this particular space, it's about politics. And we hear a lot from what they call the wings, the people on the far left and far right. And the way they look at it, that's actually not a huge proportion of the country, but they get all the attention. There's something called affective polarization, which has also infected our society, which is, if you're on the wing, let's say you're on the left, your impression about the people on the right is much more radical than they are. And if you're on the right, your impression of people on the left is they're much more radical than they are. And again, a lot of rhetoric that goes on in social media and by our politicians feeds into that. I wish we'd sort of take the word radical out of our language when we're talking about somebody who's an American. But if you look at the diagram, the people in the middle, those 67%, they're still kind of reasonably not happy about what's going on, but not aligned with the wings, and they're exhausted. They're like, can we please stop with all this animosity? And many of them kind of checked out. But we are the people. They are the people we need now, I think. Maybe, I feel like I'm part of that, maybe you are too. Maybe we need to rise up and try to make something better happen instead of this terrible polarization. Because it has gotten to the point where it's not enough that your side has to win. The other side has to lose. As in this cartoon in the New Yorker, the two dogs talking to each other in the bar. It's not enough that we succeed, cats must also fail. Well, we laugh about it, but look at what's happening now in some of the conversations you'll see. So how do we get here? Well, I think some of our traditional anchors that have kept us in a healthier place have been lost, or at least have been frayed. Truth. Is there really such a thing? Aren't we postmodern now, where there is no truth, it's just your truth? Is it okay to say that might be true for you, but it's not true for me if you're talking about whether the earth is flat or not? Science is caught up in this. People are beginning to doubt whether science is giving us truth. Isn't it biased? Doesn't it make mistakes? And what about faith? Why have our faith communities not been in a better position to resist this by putting forward love and grace and truth? But instead, it seems like faith communities have been particularly caught up in a lot of the misinformation. The group most likely to resist the COVID vaccines were white evangelicals. I'm a white evangelical. But all of the messages that were going out hit them particularly hard. And then what about trust? What's happened to our ability to figure out how to trust rationally about who is it that you can actually be confident is giving you a straight scoop and who is not? Well, let me unpack these 4 things, truth, science, faith, and trust, fairly quickly. And I realize I am talking longer than I meant to. I got really carried away about my personal testimony. So moving along here. So truth. Let's be clear that there is such a thing. But you have to think carefully about any particular claim, about where it sits in this circle, this set of circles, that range from absolute truth to opinion. And if you get yourself in the wrong circle, you're likely to be mixed up about the argument. Necessary truth, middle circle, is basically mathematics. 2 + 2 is going to be 4 in any universe you can imagine. Very important next circle is firmly established facts. The things that we as a society have decided over time has evidence to support it. It's been tested, it's been checked, and we agree this is true. The earth goes around the sun, not the other way around. The next circle out, uncertainty, where reasonable people may disagree, but a goal for us ought to be things that are uncertain is to work at them and see if there is real truth there and then move them in to the next circle in, if we can. And then there's opinion. And no disruptions happen to society if people disagree about things that are opinion. Do men look good in shoes that have brown leather tops and thick white soles? There's a disagreement about that at my house. And it has not resulted in any disruption to our marriage. So that's okay. This is what makes life interesting, have different opinions. But let's not take something that's an established fact and decide that's an opinion because you don't like it. Facts don't care how you feel. And these days, it almost feels like people have given themselves permission to say, I don't like that fact, so I don't believe it anymore. This all brings me then to this issue about bias. I guess I will admit to you that until I got into thinking about this, I thought of myself as a purely rational creature. And I thought everybody else could be, if they were just careful about it. Presented with evidence, you would always come up with a rational response that reflected the truth. In that regard, I was kind of a Cartesian. Rene Descartes, I think, therefore I am. Well, not all philosophers saw it that way. David Hume, the famous retort, reason is and ought only to be the slave of the passions. Well, we can see that in real life, can't we? I actually like Blaise Pascal's view of this. It's a little gentler than David Hume, plus Blaise was a remarkable Christian whose Pensées are worth reading if you have never done so. The heart has its reasons, which reason knows nothing of. Okay. Well, I'll tell you one other philosopher that I've gotten interested in, although not a Christian, and somebody who's a little hard to read, but this is Willard Van Orman Quine, who has this image of the web of belief, and this has helped me. Let me see if it helps you. And that is this idea that all of us have, pre-existing at any given moment, in our head, a sense about what we think is true, and it's not all equally confident in terms of the truth, some parts of it more than others. It's like a web, and if there is something in the center of your web, a node there, you're really attached to that. And if somebody's going to come along and try to knock that out, you're going to resist. If it's further out, oh well, you know, maybe it could be discussed. So here's my web. I do believe science is trustworthy. You're not going to convince me that it's not, unless you've got really good evidence. Now, let's be clear, science that has been replicated and tested and confirmed. I think my wife loves me. If you try to tell me otherwise, I'm going to resist you unless you have really good evidence. My cat loves me. I think so, but she's a cat. So, all right, it would not break my heart if somehow I discovered she'd moved next door and abandoned me, because that's what cats do. Jesus died for me. Yeah, I believe that. And the resurrection is true. I believe that too. It really happened. That's central to my faith. When it comes to other kinds of areas of faith, I'm a little mixed up about pre- and post-millennialism, so I'm not going to hang my hat too heavily on any part of that, so it's a little further out. On to health things. Vaccines are safe and effective. Well, yeah, but not always, so that's why that isn't quite in the middle. That's how safe and how effective, and are they going to be better than getting the disease? That's the question. Public health needs experts, yes, but it also needs public input, so I didn't put that right in the middle. The CDC is always right. No, that didn't quite always happen. Well-intentioned for sure. Was mandating masks in schools essential? At the time it felt like we got to do this, but maybe that was overstating. Climate change is real, you bet it is. That is undeniable. Yes, Joe Biden won the 2020 election. I don't want to spend time on that. And this one, which is not so popular in some circles. Structural racism in the United States, built on 400 years, coming out of our history of being a slavery country, it's real, and we have not completely gotten past that. So think about that. Maybe you want to make your own web at some point and decide, because it will tip you off to places where you're flexible and where you are not. Now, science. Science develops hypotheses, experiments, replication, makes mistakes, ultimately self-correcting. This picture, that's my former lab when I was able to be there before March 1st. All people working on diabetes and that disease called progeria, very dedicated to finding truth and doing something to help people. But now I have to say, the future of American progress in medical research right now is at serious risk. We've made remarkable progress. We've been on a roll. Significant improvements in cancer, heart disease, HIV/AIDS, which used to be lethal, now associated with long survival, cystic fibrosis, I mentioned GLP-1 drugs, I don't know how many of you are taking them, a lot of people are, curing sickle cell disease, and on and on and on. We've been leading the world in these kinds of breakthroughs. But now, that whole enterprise is under attack, major proposed budget cuts, thousands of grants terminated, and research universities under threat. The scientific community demoralized, more threats now in the last day about firing even more people, even though at NIH already 2,500 people were let go, mostly without any justification. So what's going on here? There's a disconnect. I think most Americans, if you ask them, appreciate medical research, but may not appreciate what's happening this year to that enterprise, which has been set back more than anyone could have imagined in just the space of about 8 months. One of the things I'm doing right now is to try to get the word out there to everyday Americans that medical research really is something you'd want to care about. In a program called We Are Living Proof, putting stories in front of people about real Americans who have benefited from medical research. Maybe somebody with stage 4 cancer who's now in remission, or somebody with cystic fibrosis who's now living a pretty normal life, or a family who has a child with a rare genetic disease that's on the brink of being cured, but that clinical trial just got stopped. Those messages need to be out there, and I think that's the only way to break through what is otherwise a pretty demoralized American community that just doesn't really pay much attention anymore to these things. Okay, what about faith? Again, this ought to be the place where we could approach our current divisiveness with positive benefits, because faith can answer questions science can't help with, should be an anchor in the storm, and should be able to advocate against the divisiveness and the animosity, and for love, grace, and truth. Our Christian calling has a lot to say about this. Love your neighbor as yourself. Love your enemies and pray for those who persecute you. Your enemies, you're supposed to love them. How are we doing on that? And here's John chapter 8. Jesus' words, you will know the truth will set you free. You ought to be in a particularly good position as Christians to be able to claim the truth. And a very sober warning. This was pointed out to me by Deb Harsmet, Lotus, a couple of years ago. Read these words. These are 6 things the Lord hates, 7 that are detestable to him. Haughty eyes, a lying tongue, hands that shed innocent blood, a heart that devises wicked schemes, feet that are quick to rush into evil, a false witness who pours out lies, and a person who stirs up conflict in the community. Wow. That does feel like a lot of what we are seeing right now, and I don't think Christians are immune from some of those behaviors. Talk talking to myself here.
We have 15 minutes left.
And then there's trust. Oh my. Bill, your questions are going to have to be really concise. I'm sorry. I've done it again. Okay, quickly, trust is a critical part of this. How do we decide who to trust? Well, the problem right now is that trust is being eroded in almost everything. Look at this diagram of what's happened since 1977. All those arrows going hard to the left in terms of percent of people who trust a particular organization. And how is it we decide how to trust and what's happened to it? I think basically we have 4 ways that we, consciously or not, assess a claim and decide whether to trust it. Is the source, does it have integrity? Is it competent? Is it humble and willing to say, I don't know everything? But then there's this 4th one. Does that source align with my values? You're doing that. And especially when we're often tribal alliances, that potentially is not helping. And it tends to kind of take over. So if you have a source that's in your bubble that's actually spouting nonsense, you might even take it seriously because, hey, that's one of my people. And if you have another source over there in some other bubble that's telling you something really important and true, you're like, well, I can't trust those people. We're all doing that. If you look at various threads on the internet, you will immediately perceive that your attitude towards a particular claim depends on what was that source. So what are we going to do about this? How do we find our way back? Well, I think it's up to us. We need to re-anchor ourselves as Christians in biblical, not political principles. We need to do a better job of telling the difference between facts and fakes. We need to engage with family and friends outside of our bubble, which we've sort of stopped doing. More listening, less shouting. This is where Braver Angels has taught me a lot. And if you're not aware of this organization, look up braverangels.org. They have chapters all around. You might even want to join them and see what that's all about. Help the kids, because I think the kids are particularly demoralized, discouraged. Many of them haven't actually experienced a culture that was actually benevolent. They've only grown up with this place where everybody is opposed to everybody else. Seek out opportunities for dialogue, demand character, vision, and positive action from your national leaders. That would be a different thing. And maybe consider signing a pledge. This is a pledge that's in the book, The Road to Wisdom, which I won't read for you. But again, it's an opportunity or maybe a calling to not just think there's a problem, but make a pledge about what you're going to do about it. Reaching out to other people. Being more clear about facts versus fakes. And I just mentioned the book, and this is what I've told you is a bit of a quick version of what's in the book about my own struggle to discern the path. But the better answer about wisdom, which I'll finish with, is from the Bible. This is a beautiful calligraphy of 2 verses from the book of James, drawn by my daughter. But if any of you lacks wisdom, let him ask of God, who gives to all men generously and without reproach, and it will be given. And what's that wisdom like? Pure, peaceable, gentle, reasonable, full of mercy and good fruits, unwavering, without hypocrisy. That's what we need. I'm pleased to have had the chance to run through all of this, and apologize again that I went on a bit long. But thank you very much.
Thank you very much, Dr. Collins. I want to introduce our moderator for Dr. Collins. We're going to have time for just a couple questions, and he's picked some questions. Dr. Phillips is a graduate of Juanita College and MIT, and he's joined the National Institute of Standards and Technology. He's currently a professor of physics at my alma mater, which is University of Maryland College Park, yay! College of Computer and Mathematical and Natural Sciences, and that's my college. I'll turn it over to questions.
Thank you very much. I'm always impressed when I hear you talk about how much we agree on. So I'd like to ask you about something that we have sort of famously or publicly disagreed on. And that's challenge trials for vaccines. And for those of you who don't know, the idea of a challenge trial is you deliberately give people the virus, and half of them have been vaccinated, half of them haven't. And this way, you find out really quickly whether the vaccine works instead of having to wait for people to get infected naturally. And I advocated that based on, in large part, my Christian principles. And Francis advised against it, based also on your Christian principles.
Exactly.
So, what do you have to say now?
All right, Bill, I knew I could count on you to come up with something provocative here. So yeah, I totally get, because it's a very powerful way to find out quickly whether a vaccine works or not. You vaccinate a bunch of people and you expose them to the actual virus. So you know they got exposed. You're not having them walk around and wonder if they ran into it. So you can do smaller numbers of people and you get a very rigorous answer. But is it ethical? I think it's ethical if you have what you know to be an effective treatment for the disease. So we actually do these challenge vaccinations for malaria. We let people get bitten by infected mosquitoes. Then we see if they were vaccinated, are they less likely to get it? But if they get it anyway, we know how to treat malaria. They're not going to die. But with COVID-19, when we really wanted to know about the vaccine, we didn't have a treatment. We didn't get Paxlovid for another year. And so I just didn't see how it was ethical to ask people to take part in that. Even if they were going to be altruistic and sacrificial and say, take me, I don't think I'd want to be part of the study that went along with that. We have to do it a better way.
And I'd done the calculation of what my chances of dying were and figured that wasn't so bad if we could help people. On the other hand, nobody wanted somebody as old and decrepit as I was in that kind of a... But anyway, sounds like we haven't really changed our...
No, I just didn't want that headline about NIH kills Bill Phillips. It's just not going to look good.
So here's an interesting question. We're all immersed today in a culture of lies. Given this current context, then how can we actually find the objective truth of which you speak about in your new book? Now, you've addressed some of that question. What more would you like to say about how can we find objective truth? And remembering that when Jesus was called in front of Pilate, he talked about truth, and Pilate asks him, what is truth? And no answer is
Jesus
recorded.
did not answer. So I'm sobered by you're expecting me to answer. Well, part of it has to depend upon whether or not you trust experts. And that's one of the things I'm worried about right now, is that our trust in experts seems to be diminishing. There's a whole book written called The Death of Expertise. And you can hear people, including high-ranking people in the government, saying, we've trusted experts too much. We need to go with our own sort of common sense. Common sense is good, but experts have done the work. They may have spent 10 or 20 years figuring out what is true. And to dismiss them because, oh, they're experts, we've had too many of them, is really a dangerous situation. So I would start there, okay? Who really knows this issue? And then kind of look at those trust issues. Are they people with integrity, competence, and humility? If you got all of those things right, then you're in a pretty good space. If, on the other hand, it's a post that just popped up on Facebook, and it's somebody who maybe doesn't have evidence of having done the work, and maybe has made other claims in the past that weren't true, be very careful. Even if it makes you upset and angry and fearful, which is what often causes people to pay attention. We're really quickly hit by that. Somebody who's telling you the straightforward truth probably doesn't spread as rapidly as the falsehoods.
Yesterday, leading up to Jennifer's lovely talk, I believe that it was Wendy gave the analogy of, imagine God has built a car, and we're now in the process of looking under the hood, maybe kicking the tires, crawling underneath, looking at the brake lines. And it was very difficult for me to avoid the image that, not yet understanding anything about the car, we open the gas cap and light a match to see what's going on inside. The reason for bringing up this analogy is that you can hear what's coming. That there's a lot of things we don't know. And what kinds of controls, if any, do you believe society should impose upon scientific research, understanding that it's awfully difficult to keep people from following their innate curiosity, and very hard to put the cat back in the bag. And as you well know, physicists are indicted for bringing the scourge of nuclear weapons into the world. And now geneticists are being cautioned about any number of things. What about that?
Yeah, well, science is a process of deriving knowledge, but that doesn't necessarily mean that knowledge is attached to a moral decision about whether it's something you should pursue or not. And that's where we need public involvement and society to weigh in. Scientists like to do science, like you said. We're curious, like, oh, let's just try that. And you can't count on science to be completely self-regulating, or things will go wrong. So, for instance, there's a big debate about whether we should use this CRISPR approach, which allows you to do gene editing on human embryos. There are increasingly people going, well, yeah, why not? We can improve ourselves. I'm horrified by that. We are already fearfully and wonderfully made, and for us to decide we're going to take charge of improving that outcome, that crosses a line into a space where we are no longer giving thanks for having been created. We're trying to do the creating ourselves. And all kinds of outcomes may happen there, not the least of which is separation from God, that I would absolutely be opposed to. But secular voices aren't necessarily agreeing quite as much about that. It's only happened once by a rogue scientist in China, but increasingly people are talking about maybe we should actually be bold and do it again. So there's an example. Another is this whole issue about gain of function research. This is kind of a buzz in the infectious disease area. If you're studying a pathogen that can cause human illness, and you want to understand, surveilling what's happening across the world, is something happening to make it even more dangerous? I'd like to know it if I saw it. So maybe in a very carefully controlled laboratory, I can assess making some changes in that particular pathogen. What is it about it that would cause me to be more alarmed? Well, maybe you're taking a risk there of creating something, if it gets loose, that could be harmful. There are people who think that's what happened with COVID-19. There's no evidence for that, but it is an issue. So some would say we should stop doing gain of function research for anything. And that's a bad idea. I mean, gain of function research can be incredibly safe and benevolent. If you're engineering a bacteria that can actually digest a sludge of oil after a spill, okay, we should celebrate that. Or I'm going to say, if your child is taking piano lessons, hopefully they're getting a gain of function out of that too. So be careful how we use that terminology in a way that sounds dismissive. But all those things are in there. And I think in this country, we've had a reasonably good community of bioethicists that wrestle with those issues. Comes and goes a little bit with politics, but it's certainly there. But internationally, we don't really have a body that has enforcement ability about ethical limits on science. The WHO tries to do that, but countries can ignore them if they want to, and that's a bit of a concern about what's coming next.
And there's so many possible follow-ups to just that issue, but we will go on. An article in the current Christian Century, asks the question, does the church still matter in the Western world? How would a young scientist answer that question? How would you answer that question?
I'm not a young scientist. I know a lot of young scientists, and maybe because my own faith has been fairly public for a while, the trainees that have come to my lab have had a higher incidence of Christianity than probably is true across the rest of the community. And I think they would say it's more important than ever. We're faced with all of these uncertainties, daunting complexities. We have society that seems in many ways to have lost its way. We're at each other in ways that are not at all what is good for us in terms of flourishing. And the Christian perspective ought to be in this space, and the church ought to be in this space more than ever. The concern is that that opportunity hasn't been quite realized, but maybe it yet will be.
Yesterday, Jennifer described her own faith trajectory as one growing up in the church and having that faith deepened as she learned more and more about her science. You had a very different trajectory, and you know plenty of people who, like myself, who have followed Jennifer's trajectory, and others that have followed yours. What do you think is, if there is any, a key difference in the way people who have had a Damascus experience, as opposed to, I sometimes refer to it as a Peter experience of slow growth, as opposed to Paul's sudden conversion? Do you see a difference in the way people approach their lives and the way in which faith influences them?
It's hard to generalize. I think God calls each of us in ways that are the opportunity for us to hear that call. And I'm, as I said, glad that I had the trajectory that I did. Also a little bit sorry I didn't have the one that you did, which would have probably enriched my faith in ways that I don't experience, because I didn't memorize all those biblical verses back when I was better at memorizing things. It gets harder as you get older. But I think we can each be drawn by our own experience to playing some role in the kingdom. Maybe I'm in a particular good place to witness to people who are skeptics, because I know what that was. But I also think, even though you're making a distinction between a Damascus moment, me in the Cascade Mountains, for instance, versus just a gradual, all the way along, deepening enrichment of faith, I think we do all have at least a moment, maybe it's not a moment, but at least looking back on it, a time where we decided, I believe this, not because I grew up with it and my parents told it to me, but I believe it. It's mine. It is, I have gone through the process of maybe thinking about walking away, and I realized, no, I want to walk back more deeply than where I was. So it's at a Damascus moment. It's a Damascus journey, but it doesn't happen like that, the way it did
the
to some.
Methodists will all recognize that as an Aldersgate experience.
Thank you, that all makes sense.
So, no, I think that Francis has been teasing us with this surprise, so it's for him to...
No, the camera people can catch up with us. Oh, you need to see your laptop. Okay.
You need help. Yes. So yeah, this is the little surprise at the end. And I appreciate everybody's patience here with what has been a longer bit of presentation and some wonderful questions from Bill that certainly could have gone on for a while. But I'm going to make you sing. And this is a wonderful hymn. You'll know the tune because it's Hipferdal, so it's Love Divine, All Loves Excelling. But the words are written by Pastor Thomas Troger, who is a pastor in Colorado. And just completely captures, at least in my mind, what we've been talking about in terms of how science and faith actually fit together as gifts from God. And because I can't change the verses, my friend here will change. There's only 3 verses. Don't worry, this is not going to go on much longer. But I will hope you will sing along. Praise the source of faith and learning that has sparked and stoked the mind with a passion for discerning how the world has been designed. Let the sense of wonder flowing from
go in peace and a safe trip home. Amen.
Amen.